Today we're continuing Unit 2, which is multi-step equations and inequalities, by talking about multivariable equations. On this first slide, what we have is, on the left, we have an example of an equation. We should be very familiar with the steps for solving this. So go ahead and write down the steps for solving that equation on the left. After you're finished with writing those steps out, I want you to observe the equation on the right. Then I want you to pause the video and answer the quick write, which says, what are some similarities and differences between the two equations? On this slide, what we see is we see a multivariable equation. Now, one of the differences that you should have noticed from the previous slide is that the equation on the right just had variables. It was the same exact equation. The only difference was, instead of having the numbers like 2x, minus, and then a number, we inserted variables. And so the steps for solving multivariable equations are exactly the same as the steps for solving multi-step equations. So in this problem, what we see is we need to solve for w. All that we're going to do is we're going to look at the problem. We've got a is equal to L times w. Now, our goal, since we're solving for w, is to get w by itself. So the one step that we have to do is we have to do the multiplication that's going on in this problem. We do that by dividing on both sides by L. That cancels the L out here, cancels the L out here, and we're left with w is equal to A divided by L. Now, what I want you to do is I want you to pause this video, and I want you to try 2, 3, 4, and 5 on your note sheet. At problem number 6, these start to they look a little more complicated. However, we're still going to be solving this problem with one step. This problem says that we solve for r. Now, our goal is to get r by itself. So what we see is we see that c is equal to 2 times pi times r. So this simple step, what we're going to do is we're going to undo multiplication. We do that by dividing. So we divide on both sides by the two pieces that we need to get rid of, which is 2 and pi. And what we'll be left with is we'll have r by itself is equal to c divided by 2 pi. What I want you to do now is I want you to pause the video and work on numbers 7 and 8. With number 9, we again have just one step that we need to solve this equation with. The reason I'm going to work this one out is because some of us are still struggling with this fraction bar and what it actually means. So, what we're doing in number 9 is we're solving for m. What we need to do is isolate m by itself. What the fraction bar means in this problem is division. So what we have to do in order to undo our division is we have to multiply on both sides of our equation by v. That cancels v out here and v out here, leaving us with m by itself, and that being equal to d times v. Now, those first 9 problems are examples of problems that we can solve with one step. Either we're dividing, or we're multiplying, we're adding or subtracting, but all of those problems can be solved with one step. What we're going to see in the next couple of slides is we're going to see that there are multiple steps that are going to have to be used in order to solve these equations. So, I want to give you guys these 3 and just kind of go over these. These are on your note sheet, but these are some hints for you to consider when you're solving these. The first hint is to think backwards of the order of operations. So we're looking for addition and subtraction first, multiplication, division second, and then we're going to deal with things like exponents and parentheses. The next hint is to remove fractions by multiplying by the reciprocal. Remember, a reciprocal is simply a fraction, so let's take 1/2 for example. The reciprocal would be that fraction flipped. Okay, the top number's coming to the bottom number's going to the top, and so what the reciprocal of 1/2 would be 2 over 1. Now, the last hint is that the last step is usually to divide by whatever is next to your variable. This is almost always going to be the case, but as we work through the next couple of slides, I'll show you what this looks like. Number 10 on your note sheet says that a is equal to 1/2 base times height, and we are asked to solve for h. So what we want to do is we want to try to get h by itself. Now, I'm going to go back one slide real quick. What we see is we're going to think backwards PEMDAS, but the second hint says to remove fractions by multiplying by the reciprocal. So what we want to do with this 1/2 is we're actually going to multiply on both sides by 2 over 1. to get rid of our fraction. Okay, so this cancels our fraction out, and what we'll have is we'll basically have 2a is equal to b times h. Now again, what we're doing is we're solving for h, so we have to undo our multiplication here by dividing by b. So the b's cancel out, leaving us with h by itself is equal to 2 times a divided by b. Now, pause the video and work on number 11. Number 12 looks confusing, but again, what we're doing is we're solving for m, and this problem is a lot the same as 10 and 11. Okay, what we're going to do is we're going to use two steps to solve this problem. Now, the first thing that we need to notice is that we are dividing by 2. So what we have to do to undo the division problem here is we first have to multiply on both sides by 2. What that does is it cancels our fraction out, and it leaves us with 2k is equal to m times v to the second power. Now again, our goal is to get m by itself, or to solve for m. So what we're going to do is we're going to undo the multiplication by dividing on both sides by what we need to get rid of. We need to get m by itself, so we have to divide on both sides by v squared. What that does is it cancels v squared out, leaving us with m by itself is equal to 2k divided by v squared. Pause the video and work on number 13. With number 14, we're getting just a little bit more complicated. Number 14 asks us to solve for w. So what we're looking to do is we're looking to get w all by itself. Now, what I want you to notice is this, is we have p is equal to 2 times L plus 2 times W. Now, there's one step that we can get rid of both of these 2's, and that's simply to divide on both sides by 2. What that does is it cancels out the 2's on the right side of the problem, and it leaves us with p divided by 2 is equal to, and then what we have left on that side is L plus W. Now, it's just one more step in order to get w by itself. What we have to do is we have to get rid of our positive L right here. Now, to get rid of a positive number, we know that it has to cancel out, so we have to subtract that number on both sides. So when we subtract L, it cancels out here. It leaves us with w is equal to, now what we're going to have on the other side of our equation is our p divided by 2 minus L. Now, these problems can get a little bit confusing. Okay, so what's important to note is that we first divided by 2, meaning we had to leave our p divided by 2 by itself. It's independent. After we subtract the L, we've got to subtract the L from whatever p divided by 2 is. Okay, so basically what we're doing is we're simplifying the problem to solve for whatever variable we're told to find. Pause the video and work on number 15. Number 18 is again one of those problems that looks a little more complicated than what it is. We're asked to solve for a. Now, what we would typically do is if we were trying to simplify this problem, is we would multiply n, which is on the outside of our parentheses, into our parentheses using the distributive property. However, we can go ahead and do our first step and simplify this problem. We're going to divide by what's on the outside of the parentheses, which is n. Now, what that does is it cancels n out, and it leaves us with s divided by n is equal to, now our parentheses are going to be gone because we have nothing on the outside to multiply it by. So what we're going to have left is a plus 1. So, now, we're trying to get a by itself. Okay, that's what it means by solve for a. So what we're going to do is we're going to subtract 1 on both sides. Now, this problem looks similar to the one we just did on the previous slide. The 1's cancel out. Okay, but what we're going to have as an answer is we'll have a is equal to s divided by n minus 1. Again, we can't subtract the 1 until we do the s divided by n. So this is our answer for number 18. Now, the last problem that we're going to go through together is problem number 19. What this says is we are going to solve this problem for f. Now this is the most complicated one on the note sheet, so if you pay close attention, I'm going to show you a really easy way to work through this problem. The two things that I want you to notice are first this. We have 5 over 9 at the beginning of our problem. So we're going to be able to take care of that in one step. The other step is going to be to get f by itself by removing the minus 32. So what we're going to do first is this. We are going to multiply by the reciprocal on both sides. So we're going to multiply the right side of our problem by 9 over 5. We're also going to multiply on the other side by 9 over 5. What that does is it cancels out our fraction, and it leaves us with 9 over 5c is equal to f minus 32. So we've gotten rid of the 5 over 9 at the beginning of our problem, and our parentheses are gone. Now, easy solution from here. We move the 32 by adding it to both sides. Now, we don't add the 32 to 9 over 5 because the 9 over 5 is being multiplied by c. So what our answer equals is we have f is equal to 9 over 5 c plus 32. Now, this brings us to the end of the presentation. What I want you to do is on your note sheet, I want you to put a star beside the ones that you might have struggled with, or circle the ones that you struggle with so that you can ask me at the beginning of class tomorrow how to do those. I'll be happy to help you out, but you need to identify the ones that you're struggling most with. Now, we're also going to go through some practice problems in class tomorrow, so make sure that you have an idea, a basic idea of what you're doing so that you can work on those when you come to class.